Hi guys. Okay, so I'm going to go over number 11, which is one of the free response questions in your Waves study guide packet. So this one, a lot of misconceptions about different types of waves, how we perceive them, and the differences between transverse and longitudinal waves. So I'll try to clarify that now. But I'd like to start by kind of breaking this up into all waves, what all waves do, and then how transverse and longitudinal are different. So all waves are going to transfer energy. So both longitudinal and transverse will transfer energy. Particles will move. Okay, we're not sure if they're moving up and down, left and right. Particles are ultimately the kind of carriers of the energy. They're going to help transfer that energy. What else? All waves are created by vibration for sound waves or disturbance. Okay, so here's kind of what they have in common. Transverse waves, you can remember capital T equals perpendicular lines. And what does perpendicular have to do with anything? So the particles, you could also say the medium, you could also say the material, moves perpendicular to direction of energy transfer. So let me give you some examples. One example that we did in class would be a crowd wave. So you are moving up and down in your seats. However, the energy or the wave itself is moving from the front of the room to the back of the room. I'm going to add to the all waves category transfers energy, not matter. So when you are in your seat for the crowd wave, you're not moving seats, you're just moving up and down. Okay, so perpendicular lines, crowd wave, what else? An ocean wave would be a great example. Most mechanical waves, waves on a string, would be transverse waves. Longitudinal, also known as compressional waves, the particles / medium / material moves parallel to direction of energy transfer. Okay, the main kind of biggest example that we've talked about are sound waves. Okay, so sound waves move in a compressional fashion, originating with a vibration. Coming back to the all waves definition, the vibration could be on a string of a guitar. It could be the vibration of your vocal cords in your mouth or in your throat. It could be the vibration of glass if you're moving your finger over a wine glass. We've looked at a few examples together. So longitudinal, particles are compressing, spreading out, all in the same direction that the energy is traveling. Okay, in terms of perceiving the waves, if we're talking about sound waves, your ears, we talked about the cochlea specifically, your inner ear, you're going to perceive. And then light waves are also transverse waves. Any electromagnetic waves, such as radio waves, would also be transverse. So we'll get into that next unit. Here are the main differences and similarities you should understand at this point. If you have any questions, comment below.